In this video, we're going to talk about quadratic functions, and we're also going to look at some examples of applications where quadratic functions are used. So these quadratic functions, and maybe functions that you've already kind of come across before, there are two forms that they can be written in. The first one is called the standard form, which you may be familiar with. That's the form f of x equals ax squared plus bx plus c. And then there's also another form called the vertex form, which is a times x minus h quantity squared plus k. Whether it's the standard form or the vertex form, so the a, b, and the c are going to be real numbers. Same thing in vertex form, the a, the h, and the k represents just any real number. So to begin with, we are going to talk about the graph of a quadratic function. So you may be familiar already with the graph of a quadratic function. What it looks like is a parabola. Okay, so in our notes here, I have two pictures of parabolas. You see the first one is a parabola where it's opening upward. Okay, so it's drawn to where you have a minimum value, and then the ends of the graph go up. And then the next one is a parabola where it opens down, so both ends of the graph are going down, and then by doing so, you have a peak on the graph. Okay, so there's a parabola where you have a valley, and then one where you have the peak. So the point where the valley and the peak occurs is called the vertex. Okay, so the vertex is a point on the graph, and because it's a point on the graph, it's going to have an ordered pair. Usually the ordered pair for the vertex is h and k. So we use the letters h and k to represent the x and the y value of the vertex. And you will notice that we also have h and k when I talked about the vertex form. So there is a reason why it's called the vertex form, is because when it's in that form, it's very easy to identify the vertex by simply looking at the values of h and k. We can tell where the vertex is. So we're going to come back and talk about these different forms later on. But for now, like I said, let's look at the graph. So as I mentioned, so your graph can go one of two ways. You can have a graph where the ends are going to be going up, or a graph where the ends of the parabola is going to be going down. So that will happen. So the direction that the ends go depends on the value of a. So you notice a is a number that's going to be in front of the x squared, or in front of the x minus h term in the vertex form. You see that we have a in both situations. Okay, so if the value of a is greater than 0, the parabola will open up, and the vertex is therefore a minimum point. Okay, so this is an example here where the value of a is greater than 0, and the parabola opens up like we said. So this is a situation where it opens up, and your vertex is down below here. Like we said, it's a minimum point. The minimum value of the vertex is k. So the y value of the vertex tells you what the value of the minimum is. Now that's the case when the value of a is positive. Whenever the value of a is negative, the parabola is going to open down. So it's going to be like the second case here. This is for values of a that are less than 0, so that's negative. The vertex is going to be on top, it's going to be the peak, so it's therefore a maximum point. The value of the maximum is, again, the value of y, which is the k value. Okay, so in this case here, this is a graph that opens down. So it opens up when a is greater than 0, and it opens down when a is less than 0. Now, a parabola is symmetric, so if I were to draw a line that goes right through the vertex, whether it opens up or it opens down, if I were to draw a line that goes right through the vertex, you will see that that line is going to be a line of symmetry, because you're going to have a mirror image of the parabola on each side of that line. So that line is what we call the axis of symmetry. And the axis of symmetry is always the value of h. So the axis of symmetry is a line. So we're going to write the line. The equation for the line is going to be the equation x equals h. H being the x value of the vertex. Okay, and like it says in the notes right here, it is a vertical line that passes through the vertex. We'll call that the axis of symmetry. So in this first example that we have here, I'm given a quadratic function, and it wants me to determine if the function is going to open up or down, identify the vertex, and then determine the axis of symmetry. So you notice here, the way that this function is written, it is in vertex form, okay? So again, going back here, we have two forms that we can write the quadratic functions in. One of them is called the standard form, and the other one is called the vertex form. You notice in the vertex form is where you have the parentheses, and then it's squared, whereas in standard form, you don't have any parentheses, okay? So that would be one of the things you can kind of look out for to know whether it's going to be in vertex form or in standard form. So down here, excuse me, down here with my function, 3 parentheses x minus 1 squared minus 2, you will see that, so this is obviously something that is in vertex form. So vertex form again is a times x minus h squared plus k. So if we want to figure out, first of all, whether the function is going to open up or open down, that is determined by the value of a, okay? So since the value of a is 3 in this case, okay, that's the number in front, that's 3. 3 is a number that's greater than 0. That will therefore tell me that my graph is going to open up. So my parabola is going to be one that opens up. Now, for finding the vertex, so the vertex is the point hk, okay? So the vertex is the point hk, the value of h and the value of k. So we are going to look at that. We're going to get those values directly from the function itself, okay? So in this case here, the h value is the 1, and then the k value is the -2. Now, to write down the point though, for the vertex, one thing you have to be careful about. So even though inside of my parentheses here, I have a -1, okay? So what this -1 actually tells me, if we go back and look at graph transformations, whenever you subtract a number inside of your function, so inside of the parentheses, it actually makes your graph shift to the right. So because your graph shifts to the right, on the right side, that's going to be a positive value, okay? So the h value is actually going to be a +1 instead of a -1. So even though we have a negative inside here in our function, it actually tells me that my graph moves to the right. And when it moves to the right, that's the positive side, okay? So my vertex, the x value for my vertex is going to be 1. And then the y value for my vertex is the value of k. So in this case here, k is -2. So when you have a number on the outside and you're subtracting, as far as transformation goes, this tells you that your graph is going to shift down. When your graph shifts down, that is in the negative side. So the -2 here is actually going to be -2. It's going to stay as -2. So my vertex is going to be the point 1, -2. That's the ordered pair for it, okay? So one way to do this, one way to remember to do this is to write the vertex, is that we're always going to have to change the sign of the h value. So you see in the parenthesis here, it was -1, but when we wrote it down, we wrote it as +1. And then as far as k goes, we are going to keep the sign of k. So if k was -2, we also write it as -2 in vertex, okay? So my vertex is the point 1, -2. So I've identified the vertex. Next, I need to determine the axis of symmetry. So the axis of symmetry, going back to the notes up here, the axis of symmetry is just x equals h, where h is the x value of my vertex. So my vertex is 1, -2, so the h value is 1. So the axis of symmetry is going to be the line x is equal to 1. Here's another example. I have another function here, another quadratic function, which is again in vertex form. And again, how do we know this is in vertex form? Is because of the set of parentheses. We do not have these parentheses when it's in standard form. So this is vertex form. My function is f of x equals negative x plus 2 squared plus 4. The first thing I want to do is to determine if the graph is going to open up or open down. So we're going to figure out this by looking at the value of a. A is a number that I have in front of my parentheses. So if you only have a negative in front of your parenthesis, we're going to think of that as being a -1. So the value of a is equal to -1. -1 is a number that's less than 0. So consequently, what that will tell you about your parabola is that it's going to open down. Remember, if your a value is negative, it opens down. And if your a value is positive, it's going to open up. As far as the vertex go, we want to identify the vertex. So like we had discussed earlier, so for the h, we have to change the sign for the h. So if you have +2 inside the parentheses, for the actual vertex is going to be -2. And then for the k, we're going to keep the sign. So if it was +4, it's going to remain as +4. So my vertex is going to be the point -2, 4. Next, I want to find the x-intercepts. So to find the x-intercepts, anytime you're looking to find what the x-intercepts are, what you're going to do is you're going to set your function equal to 0, and then you're going to solve for x. Okay, the x-intercepts means the points on the graph where your function is going to cross the x-axis. So wherever your function crosses the x-axis, the y value is 0. So the y value is 0 is the same thing as f of x equaling 0. So we're going to set f of x equal to 0 and solve for x. So in this instance here, my function is -x plus 2 squared plus 4. And I'm going to set my function to equal to 0. Next, I'm going to solve for x. So to solve for x here, I'm going to subtract 4 on both sides. So that gives me -x plus 2 squared equals -4. Next, I'm going to divide both sides by -1 to get rid of the negative. That gives me x plus 2 squared equals a +4. Remember, so I'm trying to solve for x here. I'm trying to get x by itself. So the next thing I would need to do is get rid of the square, and I get rid of the square by taking the square root. So when I take the square root on both sides, that's going to give me x plus 2 equals, so whenever you take the square root, remember that you always get 2 possible values. So it's going to be plus or minus. The square root of 4 is 2. So I'm going to write that as plus or minus 2. So this is actually going to give me 2 different values for x. I'm going to do it once where I'm going to set it equal to -2. And then I'm going to do it a second time where I'm going to set it equal to +2. So if x plus 2 equals -2, I'm going to get x by itself by subtracting 2 on both sides. That's going to give me x equals -4. And if x plus 2 equals +2, I'm going to get x by itself again by subtracting 2 on both sides. That's going to give me x equals 0. So once I have solved for x, so I found x, I got x by itself, those are going to tell me what my x-intercepts are. So I'm going to write my x-intercepts as ordered pair. So the first one is going to be the point -4, 0. And the second one is going to be the point 0, 0. So the x value is the x value that we found. And then the y value is always going to be 0 for the x-intercept. Next, I'm going to find the y-intercept. So the y-intercept is where your graph is going to cross the y-axis, and wherever your graph crosses the y-axis, the x value is going to be 0 this time. So instead of the y being 0, like it was for the x-intercept, now the x is going to be 0. So this one is actually going to be easier to find. To get the y-intercept, we're simply going to plug 0 for x, and then we're going to solve for y. Okay, so to get your y-intercept, it's just a matter of plugging in 0 for x. My function is negative x plus 2 squared plus 4, so I'm going to replace the x with 0. So negative 0 plus 2 squared plus 4. That's going to be negative 2 squared plus 4, which is going to be negative 4 plus 4, which is going to equal to 0. So my y value is 0, and my x value is also going to be 0. So my y-intercept here is going to be the point 0, 0. Next, I'm going to sketch the graph. So to sketch the graph, we can actually do this on our calculator. Let me show you how to do it on the calculator first. So to sketch the graph, we can just go to y equals, and I'm going to type in my function just like how it's given to me. So negative parentheses x plus 2 close parentheses squared, and then plus 4. And I'm going to graph. You see here is my parabola. It's a parabola that opens down, and that is something that we had already discussed. So on my sketch here, we had talked about, first of all, what the vertex was. So the vertex was at the point negative 2 comma 4. So I'm going to first plot in my vertex. So x is negative 2, y is 4. That would be right here. Next, I'm going to put in my intercepts. So my x-intercepts were negative 4, 0, and 0, 0. So there's negative 4, 0 on the x-axis, as well as 0, 0 on the x-axis as well. And then the y-intercept was also at 0, 0, which we already plotted. We discussed how our parabola is going to be opening down. So from the vertex, I'm going to draw my parabola opening down. So it's going to look like this, which is what we had graphed on the calculator. So you can use your calculator to help you with this sketch. Next, I want to find the axis of symmetry. So the axis of symmetry is just the x value of the vertex. We had found in part B that the vertex is negative 2 comma 4. So the axis of symmetry is going to be x equals negative 2. With that, we now want to determine the maximum or the minimum value. Well, because our parabola opens down, you notice that our vertex is a peak. So if it's a peak, that's actually going to be a maximum. So here we have a maximum instead of a minimum. And the value of the maximum is the y value where the peak occurs. And here you will notice that it occurs at 4. Okay, so my maximum value is going to equal to 4. Lastly, on this example, they want me to find the domain and the range. So for the domain, we can go back to either looking at our graph or we can look at our function. So remember, going back to domains of functions, we need to watch out for square roots and fractions. A quadratic function does not contain any square roots or fractions in it, so the domain will be all real numbers. So all real numbers, we can write that in interval notation as negative infinity to positive infinity. we would also see that by looking at the graph. Remember, the domain has to do with the x values, so we're going to look at the graph from left to right. So how far to the left does your graph extend, to how far to the right it extends? Because your parabola is going to keep opening, so it's going to keep extending to the left and to the right, which means from negative infinity to positive infinity. For the range, we're going to determine the range by looking at the graph. So for the range, we go from the bottom to the top. We have to see how far down the graph extends to what is the highest it reaches. So as far as going down, it's going to keep going down. When it keeps going down, that's towards negative infinity. That's the bottom part. And then all the way to the top, the highest point your graph reaches to is at 4. So we're going to write it from negative infinity to 4. The point at 4 is included, so we are going to put a bracket there at 4. So here we have our domain and the range for this quadratic function. Next, we're going to look at a quadratic function that is in standard form. Standard form, remember, is in the form f of x equals ax squared plus bx plus c. So whenever we have a quadratic function in standard form, it is not as obvious to figure out by looking at the function where the vertex is going to be. So instead, we're going to have to use a formula to determine the vertex of our function, and that formula is given in the notes right here as negative b over 2a and f of negative b over 2a. So it's in two parts. So the first part will represent like your h value, and then the second part represents your k value, okay? And another way to think about it, remember, so the h value is also happens to represent the x value of the ordered pair, and then the k is the y value of the ordered pair. So I'm gonna first do negative b divided by 2a, and then whatever you get, I'm gonna plug it into the original function to get the k. The value of a and b that are in the formula are the a and the b values that are in my function in standard form. So for example, right here, I have my function f of x equals negative x squared minus 4x minus 7. So this is in standard form. We know that because you notice there is no parentheses or anything. The parentheses only appear when it's in vertex form. So here, my value of a is negative 1, because negative x squared is the same thing as negative 1x squared. B is equal to negative 4, and c is equal to negative 7. So what I'm going to do first is I'm going to figure out negative b divided by 2a. So that's going to be negative, the value of b is a negative 4, divided by 2 times negative 1. So that's positive 4 over negative 2, which is going to equal to negative 2. What I'm going to do now is I'm going to do f of negative b over 2a. What does that mean? That means we're going to take the negative 2 and plug it into f of x. Okay, so we're going to now find f of negative 2. So I'm going to replace x in my function with negative 2. So negative in negative 2 squared minus 4 times negative 2 minus 7. And you can figure this out on your calculator. That's going to come out to negative 3. So my vertex here is going to be the point negative 2 comma negative 3. There is the ordered pair for the vertex for this quadratic function that was in standard form. Let's look at another one. So next I have the function f of x equals 2x squared minus 10x minus 5. So again, this is in standard form. The value of a is 2, the value of b is negative 10, and the value of c is negative 5. The first part is asking me if the parabola is going to open up or down. We determine that by looking at the value of a. So like we said already, the value of a is 2. That's a number that's greater than 0. Whenever your value of a is greater than 0, that tells you that your parabola is going to open up. So it opens up in this case. For the vertex, we are going to use the vertex formula because this is in standard form. So first I'm going to do negative b divided by 2a. So that would be a negative 10 divided by 2 times 2. So 10 over 4 is the same thing as 2.5. Next, I'm going to do f of 2.5, meaning I'm going to plug in 2.5 into my function for x. So 2 times 2.5 squared minus 10 times 2.5 minus 5. That's going to come out to negative 17.5. Okay, so I'm going to write my vertex as the point 2.5 comma negative 17.5. Now, if we are doing this on the homework and it does not accept this answer in decimal form, you can write it in fraction form. So in fraction form, 2.5 is the same thing as 5/2, and negative 17.5 is the same thing as negative 35 over 2. This would be the answer for the vertex. That would be the exact answer, okay? So if it does not accept the decimal form, you would have to write down the fraction form, okay? And if you're not quite sure how to get negative 35 over 2 from negative 17.5, you can simply type in negative 17.5 on your calculator, and then you hit math, and then you select frac, and then you get the fraction equivalent, which is negative 35 over 2. So that's my vertex. Next, I'm going to find the x-intercept. So like we discussed previously, to find the x-intercept, I'm going to let my function equal to 0, and then I'm going to solve for x. So here my function is 2x squared minus 10x minus 5 equals 0. What I have here is a quadratic equation, and I'm solving for x. Now, there are a couple of ways of solving quadratic equation. One way of doing it is by trying to factor, although right here we have something that is not factorable. So the other way of solving a quadratic equation is to use something called the quadratic formula. So the quadratic formula may be something that you have come across before. It goes like this. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We're going to replace the values of a, b, and c using the a, b, and c values that are in my function. So in this case, that would be negative 10 plus or minus the square root of negative 10 squared minus 4 times 2 times negative 5 all over 2 times 2. So that's going to be a positive 10 plus or minus. So what I'm going to do now is I'm going to figure out what's this value inside of the radical. So inside of the radical, I have a negative 10 squared minus 4 times 2 times negative 5. That equals 140. So I have 10 plus or minus the square root of 140 divided by 4. Now, unfortunately here, the square root of 140 is not a nice number. Okay, so this comes out to a decimal value. And like I discussed earlier, we do not want to write down the decimal values of our answer. We would like to give the exact answer. So the exact answer in this case would be to leave our answer in this form, okay? But what we will need to do though is we would need to separate them. So remember, so in the formula, we have plus or minus, so that means we have to add one time and subtract the other time. So we're gonna write that as two different things, okay? Now, so the x value for the first one is going to be 10 plus square root of 140 all divided by 4, comma 0. And then the other x-intercept is going to be 10 minus square root of 140 divided by 4, comma 0. Those are going to be my two x-intercepts. Okay, I'm going to leave it like this because that would be the exact form. Next, to find the y-intercept, what I'm going to do is I'm going to plug in 0 for x. That's how we find the y-intercept. My function was 2x squared minus 10x minus 5. So 2 times 0 squared minus 10 times 0 minus 5. That's going to equal to negative 5. And so I'm going to write that as an ordered pair as a point 0, comma, negative 5. That will be my y-intercept. Next, they would like me to sketch the graph. So I can use my calculator to help me with the graphing part of this. So I'm going to go to y equals. My function is 2x squared minus 10x minus 5, and I'm going to hit graph. And you see that it's a parabola that's going to open up. Now it kind of goes, it cuts off right here at the end of my screen. And that's because the vertex we had found out earlier is all the way at 2.5, negative 17.5. So negative 17.5 is going to be further down here. Okay, it's not on the screen. The screen here only goes all the way down to negative 10. So negative 17.5 will be further down. Okay, so this is the sketch of our graph. We're going to sketch this right here in our notes. So it looks something like this. Okay, so one thing to point out, and granted I probably did not do a very good job of graphing this right now, but remember we talked about how the y-intercept was at 0, negative 5. So the point where it's crossing the y-intercept is going to be at negative 5. And then down at the very bottom where the vertex is, that the y value of that is going to be negative 17.5 because the vertex is at 2.5, negative 17.5. Okay, so where the vertex is, the x value is 2.5. Okay, so there's a sketch of my graph. It's close enough to what the calculator gave me. Now I would like to find the domain and the range of this. So as far as the domain goes, again, this is a quadratic function. The quadratic function does not contain any square roots or fractions. So the domain is going to be all real numbers. All real numbers means from negative infinity to positive infinity. We can also figure that out by looking at the graph. From left to right, your graph is going to keep extending towards the left as well as towards the right. For the range, we're going to go from the bottom to the top. So the lowest your graph goes to is at negative 17.5. Now remember, negative 17.5 is a decimal value. We're going to write that as a fraction. We had figured out earlier that the negative 17.5 is equivalent to negative 35 over 2. So the bottom is going to be at negative 35 over 2. And on the top, it's going to go all the way to infinity, from the bottom to the top. and that is the domain and the range of my function. For the last part of this section, we're going to look at a couple of application problems. So these are problems where we're going to be using the quadratic function or things that we have learned so far about the quadratic function to solve these problems. The first example says a quarterback throws a football with an initial velocity of 72 feet per second. The height in feet of the ball can be modeled by the function h of t equals negative 16t squared plus 30.4t plus 5, where t is the time in seconds after release. So we want to determine the time at which the ball will be at its maximum height. So what we're doing here, it may be helpful if I draw a little picture to illustrate what's going on. So imagine this is a football field, and on one end of the football field is the quarterback, and he's going to throw a football. So typically when he throws a football, the trajectory that the ball is going to take is going to be like a parabola, okay? So it resembles a parabola. So here's my parabola. This represents the path of the football. It's going to go up, and then it's going to start coming back down on the other end of the field. So what we would like to find here is determine the time at which the ball will be at its maximum height. So the maximum height is referring to this point here on my parabola. Okay, that's where the maximum height would occur. But what this point is, it refers to the vertex. Okay, so remember earlier we talked about how the vertex is like either the maximum of the parabola or the minimum of the parabola. Okay. So when it's asking me to find the maximum height, it's actually asking me to find the vertex. So I need to figure out the vertex for my function, negative 16t squared plus 30.4t plus 5. You notice that this is a quadratic function. It's in standard form. The value of a is negative 16, b is 30.4, and c is 5. So because it's in standard form, to find the vertex, I need to use the vertex formula, which is negative b over 2a. So that would be negative 30.4 divided by 2 times negative 16. You can do this on your calculator. This is going to come out to be 0.95. Now, when we do negative b over 2a to find the vertex, okay, remember this is like the first part of finding the vertex. Typically, this would be giving us like the x value, okay? However, this time around, my function is not in terms of x, it's actually in terms of t, which represents the time. So when I do negative b over 2a, that actually tells me what t is equal to. In part A, it's asking me to determine the time, which is t, so I've actually found what t is, okay? So the 0.95 is actually my answer, and in this case, we're looking at 0.95 seconds. So that's how long it's going to take the ball to reach the peak, okay? Now, part B is asking me to find the maximum height. So now I actually want to figure out what the height of the ball is when it reaches the peak. So this time I'm actually going to figure out h. So to figure out h, what I'm going to do is I'm going to take this value of t of 0.95 and plug it in to my h function, and that's going to give me my height. So negative 16 times 0.95 squared plus 30.4 times 0.95 plus 5. You're going to evaluate this on your calculator. This is going to come out to 19.44. And the units that we're using for the height here is in feet. So my answer is going to be 19.44 feet. So 19.44 feet is the height of the ball, the maximum height of the ball. Part C says, determine the amount of time required for the ball to reach the receiver's hands if the receiver catches the ball at a point 3 feet off the ground. Okay, so when the ball goes to the other end of the field, you're going to have a receiver on that end. And the point when the receiver catches the ball is 3 feet off the ground. Okay, so the 3 feet off the ground, that represents the height of the ball at that instance. Okay, so what we're given here is we're given that the height is 3, and we want to figure out when or the amount of time, so we're solving for t. Okay, so using the same function that they gave me, I know that h is 3, and I have to solve for t. So what I'm going to do is I'm going to set my equation equal to 3, because 3 is the height. So negative 16t squared plus 30.4t plus 5 is equal to 3, okay, because that's what the height is equal to. The height is 3. Now I have to solve for t. So what I have here is a quadratic equation. When you're solving quadratic equations, the first thing you need to do is you need to set it to where it's equal to 0. So I'm going to do that by subtracting 3 on both sides first. So that gives me negative 16t squared plus 30.4t plus 2 equals 0. Now I'm going to solve for t by using the quadratic formula. So the value of a this time is negative 16, b is 30.4, and c is now 2. Notice that the value of c has changed. Okay, so plug it into the quadratic formula. It's negative b, so negative 30.4. I'm going to say right here, use quadratic formula. So negative 30.4 plus or minus the square root of b squared. So 30.4 squared minus 4 times a is negative 16 times c is 2, all over 2 times a, which is negative 16. Okay, so negative 30.4 plus or minus the square root. So what I'm going to do now is I'm going to figure out what's inside of the radical. So I'm going to evaluate inside the radical. 30.4 squared minus 4 times negative 16 times 2. That is 1052.16. So inside of the square root, I'm going to have 1052.16 divided by 2 times negative 16 is negative 32. And what I'm going to do at this point is I'm actually going to split it up. Okay, so like we did before, so when I use the quadratic formula, it's plus or minus, so that's going to give me 2 different values. Okay, I'm going to get one value by adding, so negative 30.4 plus the square root of 1052.16 divided by negative 32. Let's see what that gives us. So negative 30.4 plus the square root of 1052.16. I'm going to see what that equals. And then I'm going to divide that by negative 32. So that gives me negative 0.06. And then I'm going to do it a second time where now I subtract the square root of 1052.16. So negative 30.4 minus the square root of 1052.16. I'm going to hit enter, and then I'm going to divide that by negative 32. That gives me 1.96. All right, so I have two answers. One is negative 0.06 and the other one is 1.96. Remember, what we're trying to figure out here is the time, how much time it took. So it does not make sense in this case to have a negative amount of time, okay? So I'm going to ignore this value. My answer here is going to be the 1.96 value. So it's going to take 1.96 seconds for the ball to reach the receiver on the other side of the field. For the final example of this section, we're going to look at another application problem. This one says a farmer has 200 feet of fencing and wants to build 3 adjacent rectangular corrals. So we can draw a picture first here so that you know what is going on. So we are going to imagine having 3 rectangles. Adjacent means they are right next to each other. Okay, and this farmer has 200 feet of fencing to fence off this little area. Okay, we want to determine the dimensions that should be used to maximize the area. Okay, so we want to figure out the dimensions. So the dimensions refer to the length and the width of my rectangle. Okay, so actually here, so we can think of this as one big rectangle, and then we're going to divide it into 3 parts. Okay, I believe if we go that route, that would be easier here. So we don't know what the sides would have to be, so we're going to go ahead and label this side X. And if that side is X, then that means this side up here is also going to be X. That would be the length. And then for the width of my rectangles, I'm just going to call those sides Y. All right, so I know that I have 200 feet of fencing to fence off all this area right here. So that means if I were to add all the sides of these rectangles, that will have to add up to 200. So I can get an equation, okay? My equation would be 2x plus 4y equals 200, okay? So the 2x comes from these 2 sides of the rectangle, and then the 4y's comes from these 4 sides of the rectangle. So if I add 2x plus 4y, everything has to add up to 200 because that's the amount of fencing that we have. What we want to happen here is we want to maximize the area. All right, so let's discuss the area. The area here, so if we look at this as just one big rectangle, the area is the length times the width for the big rectangle. So in this case, it's going to be X times Y. I want to maximize the area. So to find the maximum, similar to how we had found the maximum in the previous example, we had to use the vertex, okay? So anytime we're finding the max or the min, that's referring to the vertex, okay? So we want to find the vertex of this function xy. But the function xy, the problem we run into here is that this is not something that's quadratic, okay? So this is not a quadratic function. It is not in standard form. So we're not able to find the vertex of it. So in order for us to be able to find the vertex, what we need to do is we need to rewrite this in terms of just one variable, okay? So rewrite in terms of one variable. So the variable that you can use is either X or Y. It doesn't matter which one you pick, but you just have to make it to where it's just one variable. So here's how we're going to get this to where it's in terms of one variable. We're going to use the first equation that we had. And what we are going to do here is we are going to solve for Y. It actually doesn't matter which variable you pick. You can pick X or Y. I'm going to go with y. So I'm going to solve for y. Solving for y means I want to get y by itself. So this is my equation here. So first what I'm going to do is I'm going to subtract the 2x on both sides. And then I'm going to divide by 4 to get y by itself. So that's going to give me y equals 200 divided by 4. That's going to be 50 minus 2/4. That's the same thing as 1/2 x. What I'm going to do now is I'm going to replace the y in my area with 50 minus 1/2 x. Okay, so what I had found for y, I'm going to plug it in here. So it becomes x times 50 minus 1/2 x. I'm going to distribute the x. When I distribute the x, that will give me 50x minus 1/2 x squared, which I can write down as negative 1/2 x squared plus 50x. And the reason I changed the order here is because whenever you're writing it in quadratic form, the x squared terms is usually first, and then the x term is second. Okay, so instead of 50x minus 1/2 x squared, I wrote it as negative 1/2 x squared plus 50x. So this is now quadratic. My a is negative 1/2, and my b is 50. I want to find the vertex. So to find the vertex, I'm going to do negative b over 2a. So negative 50 divided by 2 times negative 1/2. That's negative 50 over negative 1, which gives me positive 50. So what I have found here is what x is equal to. So x is equal to 50. So x refers to this side of the rectangle. So by using the negative b over 2a, that actually told me already what the value of x is. Okay, so x is going to be 50 feet in this case. Let's go ahead and figure out what y is. So the side y. So to get y, we're going to use what we had solved for y. So y is 50 minus 1/2 x. So 50 minus 1/2 times 50, because x is 50. All right, so that'll be 50 minus 25, which gives me 25. Okay, so the x side is going to be 50 feet, and the y side is going to be 25 feet. Those are the dimensions of the corrals. Now I want to find the area of each individual corral. So what I'm going to do first is I'm going to find the area for the big rectangle. So all three of them combined together. So the combined area is going to be 50 times 25. So x times y will give me the combined area. So 50 times 25 equals 1,250. It wanted me, though, to figure out the area of one of the corrals. So I'm going to divide the 1,250 by 3. When I divide that by 3, it gives me 416.67. That would be the area of one of the corrals. And because it's an area, the units for it is going to be in square feet. Okay, so in part A, I found the dimensions. So that's the x and the y side of my rectangle. And then in part B, I was able to figure out what the area is. It wanted the area of one of the rectangles, so I found the combined area and then divided it by 3. All right, that's the end of the section on quadratic functions.